All right, so solve quadratic equations. So I'm just going to kind of like work my way up. I'm just going to make up some problems, and I just want to kind of explain some things because there's some very, very common issues that I have seen a lot that's been working on. So we have ax squared plus bx plus c. Okay, so let's do x squared minus 5 equals 0. Let's do x squared. You know what? Let's do, I'm just going to make this factorable. You could do 5, but I'll try to keep things fairly basic. Let's do minus 4 plus, minus 4x plus 3 equals 0. And then let's do x squared minus 4x minus 3 equals 0. Oh, actually, you know what? Let's change this. Let's have some fun. Equals plus 3 equals 3. There we go. Perfect. All right. So when we're solving quadratic equations, now actually I should probably even add one more here. So just the other equation, well, yeah, let's just do a quick little like 2x minus 1 equals 5. Okay, so if I said to solve this, right, that's a linear equation. Now again, for the linear equations, when you learned how to solve, you isolated the variable, right? So we add a 1 to both sides, and then we'd have 2x equal to 6, then you divide by 2 on both sides, and x equals 3. Right? So that was our solve. That was using our inverse operations. So the problem is a lot of students always want to solve quadratic equations just like they solve linear. Well, sometimes that works, but majority of the time it does not work. And let me explain. You could solve this using inverse operations. This is x squared minus 4 equals 0. Now, the reason why you can solve this like a linear equation by using your inverse operations is because there's only one variable. Now, that variable is raised to the second power, which tells us it's a quadratic. But since there's only one of them, you can just isolate the variable using inverse operations. So you could just add a 4 to both sides. And then the inverse operation of squaring would be the square root. But again, it's the plus or minus of that square root, right? It's actually inverse operation is plus or minus the square root. So therefore your answers are x equals plus or minus 2. Again, notice for a linear equation, we had that one answer. For quadratics, we have 2 answers. Now again, that's not always going to be 2 answers, but the maximum number that we learned in polynomials would be, or in our chapter of polynomials, is going to be 2. Now again, we could also factor this, right? And that's what I'm going to do next here. Now it's really nice that this is equal to 0 because, and that's one of our key components that when we're solving quadratics, you know, obviously if we're using the inverse operation, just get it to the other side and solve it. Like you only have one variable, that's good. But if you cannot use, or if you're going to use factoring or quadratic formula, you want to equal to 0. For factoring, we want to equal to 0 because we want to use the zero product property. And again, the zero product property states if you have a product equal to 0, then one of those products has to equal 0. So x equals 2 and x equals negative 2, which is exactly what we got here. So in this next example, again, I want to see like factoring. Now again, this is like a trinomial, and again, to kind of keep things rather short here, I'm not going to explain in depth the quadratic factoring. We basically are looking for what two numbers multiply to give me a positive 3, add to give me a negative 4. Thankfully, there's only some numbers that multiply to give me a positive 3 that add to give me a negative 4, and that's only one, negative 3 and negative 1. Now I have a product equal to 0, so I can just apply the zero product property, and I get my answers very nicely. Now, the biggest mistake here, and the reason why I change this, is because students say, oh, well, let's just square root, or let's add the 4x and then take the square root. And I say, no, you have two variables. You have an x squared and x, right? You have a quadratic and a linear variable. They are not like terms. You can't combine them. You can't use inverse operations. You can only use inverse operations when you only have one variable. So in this case, what we need to do is we need to set it equal to 0 to look to factor it. And unfortunately, this is non-factorable because the only two numbers that multiply to give me negative 3 are going to be negative 3 and positive 1, or negative 1 and positive 3, and neither of those add up to a negative 4. So when I have a quadratic, ax squared plus bx plus c equal to 0, I can use the quadratic formula. So the quadratic formula says the solutions to a quadratic are going to be opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So again, like we're trying to solve for x, right? The solutions, the values of x that make that equation true. So therefore, I can say my a is 1, my b is -4. So when we're doing the quadratic formula, when we're first learning this, I like to just list them. And now we're just going to plug those numbers into the quadratic formula. So the opposite of -4 is +4, plus or minus b squared, which is 16, minus, let's see, a 4 times a times c. So 4 times a times c is going to be a -12, divided by 2 times a, which is 2. All right, and then we simplify the radicand. That's going to be, what, a 28? Then, using what we learned in previous, we can see what square number divides into 28. Well, I know 4 does. 4 goes in there 7 times, right? So I can take the square root of 4, which would be 2. So this would be 4 plus or minus 2 radical 7. And again, for those of you that are not following along, that's 4 times 7. Square root of 4 is 2 radical 7. And that's over 2. And then you can divide the 2 into both of those. So therefore, I'd have 2 plus or minus the square root of 7. So that is what x is going to equal. So x equals plus or minus the square root of 7. So again, just solving quadratics. I mean, typically the fastest, the easiest thing to do is looking to factoring. That's why I think it's so important to really be strong with factoring. However, if you only have one variable, you can use inverse operations. Obviously, if something's non-factorable, then you could use the quadratic formula. You could also do completing the square. But I think for most students, quadratic formula is going to be preferred.